quick show of hands in the room. How many people before this talk are aware that eBay just rolled out a big cluster? About 10%. So in the next half an hour, what I would be doing would be walking you through the incredible journey we went through in the last 3 to 4 months to roll out our big cluster. We believe it's the third largest cluster right now in the industry based on the public information. At any given time, feel free to drop me the questions, although we'll have a Q&A session at the end as well. So looking into a brief history of time of the usage of Hadoop at eBay. We started with a small cluster in 2007 where our research team actually got together to build out a 4-node cluster to do some basic clickstream and visualization analytics. Fast forward a couple of years, in 2009, our search team actually started getting interested in this technology and built up a couple of clusters on machine learning and search relevance and factor generation. As we went through the process of building these clusters, one thing we learned was that these clusters were extremely small. It's very difficult to do any big analytics. Any big analytics required huge data sets so that we can run against that. So back late in 2009, some of our executive team got together and said, hey, how do we actually complement some of our core data warehouse technologies which are being used for structured data analysis with a lot of the unstructured and semi-structured data. And that's when we made a decision that we as a company need to invest in this technology. And we wanted to build this as a platform so that we can support multiple dedicated teams down the line. For those who are probably following eBay as far as some of the blogs must be aware that eBay has a great enterprise data warehouse system which we use for a lot of our analytics. So the goal was to actually build this to complement that system. And some history on the rollout itself. We started with the interviewing process sometime in December last year, and the goal was to actually build out a cluster of a couple of racks of 76 nodes in April with learn your way into it, and then probably around July we want to build out, let's say, a 500 node cluster. This was the first project I worked at eBay where the timelines actually got pulled in by a couple of months. And on top of that, the team rallied to deliver this 15 days ahead of schedule. So you just see the urgency within eBay to get into this space. After the cluster was built out, we went through a naming contest, and there were names around what should we call it. There were names around Hathi, there were names around Mars. People wanted to call it Faraday, but we ended up with the name Athena, and Athena is symbolic for a couple of reasons. It is actually the Greek goddess for civilization, craft, and wisdom. And Athena, incidentally, as Franco in this room pointed out, was the name of the project at MIT, which incubated a lot of distributed system development, and a lot of innovation over the years actually came out of that project, whether it was Kerberos, which is now being used in Hadoop, Active Directory, LDAP. So a lot of innovation came out, so we thought this was extremely symbolic to call it Athena.
Any reason why it's 532 nodes?
Yeah, I'll cover that. That's a very good question. I'll cover that in the next slide. So what exactly is Athena? It is a bunch of enterprise servers and data nodes going into how Yahoo, Facebook, and some of these pioneers have actually done work in this. We wanted to look at and leverage similar architecture around that. So on the enterprise node side, we are using some 64-bit boxes. We are using Red Hat Linux. These are 2 quad-core Nehalem processors. And what you see is a bunch of standard servers which are being used. We use Cloudera and the Hue. It's been rebranded as Hue, or the Hadoop user environment. And then that's been used for some of the basic users. And some of the advanced users actually want command line, so we also have a command line server there. On the data node side, to address the gentleman's question here, we came out with 532 nodes, and each rack is actually packed with 38 nodes. We looked at different architectures, and we wanted to build out something which is extremely dense from a computing perspective. And we leverage STI rackables, which provide a great architecture there with 1U units. So we can have a dense environment to limit the intra-rack chat between racks. We have a 5.3 petabytes across, each of them has 10 terabytes. And these are again 2 quad-core Nehalem processors. And we have tried and leveraged HBase on about 20 nodes. On the net,
how many drives is that for 10 terabytes?
Each of them is 1 drive, 1 terabyte, so 10 of them. Yeah. On the networking side, we are using the standard top of the rack architecture with 1 gig uplink to the top of the rack, and about 40 gig to the core switches. And the reason we are using 40 there is to have something called the line rate, to make sure that we have enough bandwidth as these racks start communicating to each other. We can go to that next. On the ecosystem side, looking at Hadoop with a bunch of layers, at the bottom is really the core and MapReduce. So a lot of our data sourcing today is actually, we've leveraged Java and a bunch of Scala and other tools there to build our key data sourcing jobs. And I'll cover in the next slide of what the data sourcing is and the patterns. On the data access frameworks, we did an evaluation of all these different frameworks which are being used right now. We believe both Pig and HBase have their strengths, and we want to leverage both and provide that to our partners. Pig primarily is going to be used for a lot of the data pipelining jobs and going to be used by developers as the key actors to them. While on the Hive side of things, we believe analysts should be able to run with it, and it would support ad hoc queries, because that's where the strength is, with HBase at the back. And we also have a homegrown language. This was invented prior to Pig and Hive itself, called the Modus query language, which is geared towards visualization and clickstream analytics. On the tool side of things, as I covered, I mentioned briefly, the Hue tool is being used. We also had a homegrown tool which was being used to manage the workflow and life cycle of jobs. So using a combination of those and tied those together through common authentication. We are using enterprise scheduler called UC4, which is responsible for scheduling jobs from outside over into the cluster. Uzi, we have been really keeping a close eye on that. We saw all the development in the Hub meeting in the last month.
How do you load data into the system?
That covered that, and probably I'll spend about 10 minutes on that. Now, Uzi is being used for, or is being evaluated for a lot of the user workflow, and as we build these different pipelines, we want to leverage that. And Mahout is being used to do a lot of our machine learning. And on the monitoring and alerting, with the combination of Ganglia and Nagios, we want to have some basic monitoring and alerting for our operations, while we are looking deeply into some of the other monitoring. We're keeping a close eye, and I'll cover that in the end. Moving on. Thank you. On the administration side, we built it as a platform, so we need to support multiple groups onto this. And the way we've done this is by having the job invocation itself tie back to the group name. This is both on as far as the Hue environment is concerned, as well as the command line. So this way, anytime a user runs Hadoop or Pig or Hive, the tool name or the group name automatically gets appended as part of that, so that they get correctly allocated. Which brings me to the next part, which is really the fair scheduler. So we are leveraging fair scheduler in a big way. And the simple policy we went with as far as fair scheduler was concerned was really have the allocation based on investment. So if a business unit invested X%, we just allocate X% to that. And then we set minimum mappers and reducers based on the SLAs. So this way, you not only get the SLAs, but you're getting allocation based on that. And weights are also being set up for cases which are non-SLA jobs. Besides that, there are minimum shares. Besides that, there are pool-specific and user-specific defaults which we've set up. And then Fair Scheduler currently supports a bunch of preemption timeouts as far as whether it's fair sharing itself, which looks like deficient, or the min share, which gets kicked in when it has to kill certain jobs. Besides the fare scheduler on the auth and auth side, we wanted to tie the authorization with a lot of our internal corporate policies around authorization. So with Hue, what we did was we extended Hue, so Hue supports some kind of pluggable extensions by which we actually tied it to our corporate authentication. And then the other thing we ran into was that as Hue was used by basic users, some of the command line users still would get on using a different authentication. So what we're doing is we are writing our own PAM custom modules. Unix supports something called pluggable authentication modules, by which we'll again tie them to our corporate policy, so that way we don't have to have two authentication systems. The other thing I'll point out is, Owen and the team have done a lot of work on security as far as Yahoo is concerned. Yahoo internally is using Kerberos in a big way. We at eBay have our own corporate authentication system. So now what we are looking into is how do we actually go and implement some of the delegate tokens and the other tokens being provided in the Hadoop security to actually again tie it to our own SAML or our own internal authentication. We can go to the next slide. So the real meat of this presentation is really the data sourcing patterns. Prior to Hadoop, I mean, all of our critical data was in some different systems. So one of the goals of Hadoop was also to make sure our developer community or our analysts are not running around for different data sets in different systems. And we wanted to get some of the critical data into one place so that we can run machine learning and other analytics on this. So some of the key data which is actually getting into the cluster right now is our clickstream data, which is really our behavioral data as the user is navigating through the site. We have key domain areas from our enterprise data, warehouse data, and I'll cover that in detail, especially things around our item, our transaction, our transactional data, as well as our user feedback data which is coming in. Besides that, today a seller could go in and when they create an item on eBay and they're trying to sell, they create a free-form item description. So that item description is a rich amount of text which we are trying to get into the cluster. And besides that, all the items today when they get listed, whether they are stock photos or custom photos by our seller community, even that needs to come into the cluster, and there are use cases around that. Now the way we actually get it into the cluster is we have a great framework there, and we call it the ingest or the acquisition framework, by which we can source all this data to that framework or that set of nodes. From there, we follow different patterns as far as loading the data, and I'll cover that as we go further per data set. Now, taking maybe the clickstream as an example on what we're doing there is, any user, as I described on the behavioral side, is navigating the site. So taking this with an example, let's say the user starts with Yahoo search engine, searches for something in the paid search, clicks maybe an eBay link, goes into eBay, searches for a few items, navigates the site, decides something to buy, goes buys it, and then checks it out. So that whole process is really the clickstream data which gets collected on behalf of this user, and then this gets sessionized. So there's the notion of event data, which is really a sequence of events, and standard web analytics is really a session which is related to this. Now, each of these today are getting fed into as LZO. So we use LZO to feed this. There are some great blogs by a gentleman called Johan Oscarson. He was from Last.fm, and I think he's now joined Twitter based on what I saw from those blogs. Who's done a lot of good work on this side. So what we did was we looked at some of those blogs and leveraged that pattern to feed this data in. What that pattern really does is the LZO has those blog boundaries, but we actually now start looking into walking through those boundaries and creating something called the indexer on it. So each of that indexer really has an offset of the partitions themselves. And then it exposes something called the LZO text input format, which basically goes through that indexer, figures out the splits, and then provides that to the multiple mappers. So this way, that pattern helped us solve our problem of scaling the data loading itself into Hadoop as far as the session event data is concerned. One of the other things we ran into was any job which wanted to actually meaningfully use these two data sets would need a join. So they needed, let's say, the session data followed by all the event data subsequently following it in a chronological order. So we had to use standard patterns in Hadoop called the secondary sort, or it's also called the value to type conversion pattern. What that pattern really does is really gives you the ability to sort this data, and using some techniques, which is really defining your own partitioner, defining your own key comparator and a value group comparator. And this way, it helps us prepare the data in a format then our users can go and run against. On the EDW side of things, there was a lot of discovery which we went through, and I want to share our experience as far as how we approach that. So the data itself, we initially started with our partners or our users really wanted all the historical data. So that required us to do a one-time load of all these feeds. As we started development of these one-time feeds, what we saw was the data was skewed. And the skewness was purely because of each data set having different data across all these different partitions. So what we needed to do there was to Hadoop support something called the total order partition. The default partitioning is hash, but you can actually use something called the total order partitioner. And using the total order partitioner and a bunch of input samplers, which help you create this partition, so random sampler just happens to be one type of input sampler, you can actually create these partitions which will give you proper partitioning scheme and will prevent skewness. So using that combination, we actually made sure that our reducers didn't have any stragglers, as we call it, which means they were not getting killed just because some reducers were taking a lot more time than the others. And finally, what we wanted to do was to actually load them into HBase. So the goal was to actually load them in HBase, and so we created something called HFile output. So HFile actually is the native format for how HBase talks to HDFS. And then there is a load utility, which there's a Ruby script called load_table.rb, which you run against these H files, and what that does is goes and updates the configuration, the meta and the region server, so that it seamlessly gets updated. That's a very efficient way to insert or create new tables. And the kind of performance we saw on the inserts was about 135 to 150K rows per second, which is great. And so we solved the one time, and then the challenge was now, we'll be getting daily feeds for these, so there'll be incremental updates which we have to make on these existing tables. And the challenge we ran into was that although the inserts, we can leverage some of the H file and these utilities, the appends were actually doing round trips for every RPC call. So we were getting throughputs of about 15K per second. So we came out and we discovered this, and we innovated fairly quickly on this to really create something called a snapshot. So while we work on the HBase JIRAs with Cloudera and other teams, how do we kind of solve the problem for our partners? So we suddenly made that append problem to be just an insert problem. So what that means is you take the previous day's a snapshot which gets created, take the incremental data, combine them, and create another snapshot. And this way it gets rolling forward, while you wait for all the patches on the appends itself. And so what you see there is the HBase JIRAs, and the other thing we ran into was some of the work which is happening on just the durability of HBase itself. So we don't want to lose any data, and there are a lot of JIRAs on the H file flush and the sync utilities which the teams are working and the community are working. Finally, on the Hive side, we wanted to leverage Hive. So Hive is great for running queries against these data sets. It's great for the analysts. So there were two kinds of use cases for Hive itself. There were full table scan kind of use cases, which required you to do aggregation or scans across the table to get some computation or metrics. There were also use cases like, hey, I really want to do something extremely selective. For example, I really want to go to one of my item IDs and get its details. So to solve both these kind of problems, for the first one, what we did was we created the snapshot as sequence files themselves. So any any aggregate query should go against those sequence files, while any highly selective query should actually leverage the Hive and the HBase. And the way Hive actually works with HBase is you create something called storage handlers, which are non-natively managed. And while for sequence files, it natively manages it. And there's a great documentation on that front between HBase, Hive, and how you can integrate the two. You can go to the next slide. Now, going into how we are actually leveraging this for our use cases and really providing the business value. So from one of the use cases from our search is, hey, I have a problem of how do I improve my machine learning? Now, given eBay's ecosystem is so diverse, we have all kinds of users. Enthusiast in electronics is totally different than an enthusiast in clothing, shopping, and accessories. It would be totally different in how people buy toys. So how do we actually go and build ranking functions and classifiers which can actually look at these different categories to produce relevance? So what is described here is really a rudimentary view of how we look at all the different data sets to build these classifiers per category to build something called ranking functions. And these ranking functions really is a bunch of factors like could be an item price, could be an item title, item description, and really the seller's reputation. All that currently is being done in Hadoop, and the way we want to do this is we should be having the ability to build additional factors as we move on. If you go to the next. A second use case is from our research team of how they are leveraging Hadoop. A standard problem on the site, as I mentioned, is every seller goes and lists items and they provide a free form of description. So how do you now look at the description to come out with those characteristics or important name value pairs which can then be used for a lot of your clustering and data mining? So taking this with an example, a seller went and listed a Barbie doll and had a bunch of characteristics like its year, like model, edition, and condition. So how do you actually go and build these build algorithms around data mining and clustering, which can not only look for these, but then cluster them in an unsupervised way, and then feed them back to our catalog system so that we can correctly categorize and put them in the right bucket, so that when the enthusiast comes and toys comes and shops for it, he knows exactly what he's looking into and can sift through them. Sorry.
So for your previous classifiers in this, we're using Mahout, or this is done using
Mahout is one, and then we're also using gradient boost decision trees. If you go to the next. Finally, what's the road ahead for us? There are a bunch of things we want to look at from the platform side, because we're trying to build this as a platform. On the metrics side, currently Job Tracker and the job statistics it provides has few things which are there out of the box, but we realize that we need to persist some of that into databases. So we're looking into how we can actually improve some of that to have persistent job statistics. Another thing is we want to look at some of the forecasting and system disk usage models as well. As new data sources start coming into the cluster with finite capacity, we'll soon run out of those 5.3 petabytes. So we need to not only build good monitoring tools there, but also have the right forecasting so that we can have those discussions with our partners on that. And besides that, really utilization metrics of how we actually are leveraging the cluster at any given time. Again, we are looking at how the industry is doing it, and I recommend everybody reading a Facebook paper which recently came out on this. They have tons of information of how they are doing it. On the infrastructure side, we know that this is our first cluster, and we would be actually building a lot more. So how do we come out with good published subscription tools which can actually start replicating data if we need to? So that's where the published subscription. And then the other use case is really the low latency data movement. We know that there will be certain use cases which would require quick turnaround from the analytics back into the site. So how do we look at some of these low latency use cases to make sure the end-to-end is reduced? On the development side, we're trying to keep an eye of all the development happening on the tools, environments, IDE, so having debuggers, having these ability for our developers to make them more efficient. We're really evaluating some of this. On the architecture side, again, there's a lot of good development happening in the community of what we saw, especially around having a consistent metadata layer. So right now, Pig, Hive, each of these have their own mechanisms and means of dealing with metadata. And if we have to do governance schema management and put some policies around that, that's something we are really keeping an eye on so that we can start learning from that experience. On the operations side, looking definitely of better SLA monitoring so that we can start supporting some of these 24/7 use cases with better monitoring. On the reporting side of things, how do we provide visualization? How do we provide self-service? So a lot of these BI vendors are actually partnering with Hive or other data access frameworks. So we're keeping an eye on that so that we can start leveraging some of those frameworks to provide easier and quicker delivery, information delivery and visualization itself. On the security side, I think I covered that briefly, but really keeping a close eye on the Hadoop security spec and its implementation, along with what additionally we can do on the policies around permissions and groups. On the cluster side of things, we're looking now into how we should be actually expanding some of these exploratory clusters. When will be the next Hercules or Zeus coming in places? That's something we really started to talk about. And how do we actually have business goals tied to those? Because just pure investment in Hadoop means that it has to translate back into business value. So we started having those discussions. And on the production side, any high availability, the name node being a single point right now is something we're closely looking at, and looking at alternate solutions like DRBD or other high availability techniques to actually make this better, because once you have production facing traffic, you need to solve that. You can't depend on even downtime of 10 minutes even if you have standbys. And then finally, we know that there will be a federated model. There will be use case specific clusters. So how do we come out with those federated policies ourselves so that we can build up use case specific clusters, whether these are advertising, these are merchandising, and or trust and safety. On the acknowledgement sides, a few acknowledgements I wanted to make as part of that. So first is really the Athena team. I really want them to stand up. If they are here, I think a lot of them are here in this room. So I wanted to thank them and really have them stand and thank them. I think it's been a phenomenal last 4 months. It's been crazy months from 0 to 532. It's been a ride for us, and I wanted to really make sure that we acknowledged. I definitely wanted to acknowledge Cloudera. So we were fairly new as a team to all of this, and then having that expertise from them really helped us to go extremely nimbly and quickly in this space. Finally, I really want to thank each one of you in this room. And the reason is there's a lot of contribution and commitment made by everyone in this room to actually make Hadoop to a point where enterprises like eBay have actually benefited from. I mean, all the great work which has happened at Yahoo, which has been a big promoter, supporter of Hadoop, and Facebook, and some of the other companies like Twitter and others have actually helped us jumpstart to a point where we are here in like 3 months. Really kudos to all of you here for making this successful. Finally, I do want to say we are hiring, and the last thing I would end up with that, the power of the elephant, right? Don't underestimate. I think it's starting to make difference in the industry. It's revolutionizing the industry as far as how we are managing big data sets, and that's translating into business value, which each of these companies are getting out of that. Thank you.
One question only. When we're setting up.
So, big for pipelines and high for analytics, how did that decision come about?
So what you see there is big, in general, is a good hybrid between the procedural and declarative, right? So we know that developers are naturally going to go and go towards it, they gravitate towards that. And we know that Hive is kind of SQL, right? So we know that Hive would provide some of the basic ANSI SQL capabilities. So the question is, how do we now